Good afternoon and welcome to our next HAKOM webinar. My name is Stefan Komornyik and I'm co-founder at HAKOM Time Series. All our webinars are being recorded and uploaded to our YouTube channel. You will receive a direct link along with a follow-up email afterwards. Every industry is changing, and especially the energy industry. The amount of data that is being produced every single day is immense, creating the need for new concepts and data architectures to be created in order to achieve digital transformation. One data architecture that embraces the universality of data and has been adopted by many organizations is the data mesh. In today's webinar, we will explain what is the data mesh, what it can provide to data-driven organizations in the energy industry, and how our HAKOM technology fits into the data mesh paradigm by displaying the advantages that it can provide to companies in the energy sector. With us is Jonas Bräuer, Senior Manager and Expert for Digitalization in the Energy Industry at Define, a business consulting and services company based in Frankfurt. Together with Ricardo Wickert, Head of R&D at HAKOM Time Series, the three of us will unfold the data mesh concept and give valuable insights into how this architecture is applied today in a data-oriented energy industry. Now, having said that, let's start the webinar.
So, yes, let's start. Once again, it's time for Time Series. Welcome. Again, more than 200 joining today in our event. And of course, welcome also our speakers, Ricardo, our Head of R&D in Munich. Hi, Ricardo.
Good afternoon.
And Jonas Bräuer, Senior Manager of Define in Bremen. Hi, Jonas.
Nice Hello.
Hi. To all of you, please get in touch with us already during the webinar. Please use the Q&A function as always at the bottom of your screens, because at the end, we will have a Q&A session. And as usual, we want to answer all your questions. So please challenge us. Last time, we started our Time Series cloud journey. And today, we will talk about the topic relating to that very closely, the concept of data mesh. And as always, we do not want to highlight topics just theoretically, but rather point out their relevance to the energy sector and especially how they can be useful for that industry. Therefore, today we join with Define, a European consulting firm with a very interesting track record. So let's start by defining Define first. Ever since their beginnings, which was in 2002, their DNA has been an analytical, quantitative, and technical approach in a big range of fields like business and IT design, systems, selections, models and methods, and many more. And today, with more than 1,000 employees in international teams, they have expertise in various industries, as shown here in the slide. And with the energy domain being one of them, they have the who is who of the European grid companies, traders, and sales companies within their client base. So we are very happy to have Jonas here, an experienced senior manager and energy expert. And he will explain what a data mesh is and how the energy industry can make use of its data architecture principles. So, Jonas, please go ahead.
Yeah, thank you very much, Stefan, for first of all your invitation and secondly for the nice introduction. In this first part of the webinar, I would like to give a brief overview of the data mesh concept, but as Stefan also said, especially share some insights from my experience in helping clients in the energy industry to create more value from their data and to build the underlying data platforms as an enabler for value creation. So we start with the why the data mesh? And usually the discussion with our clients starts when they try to make the next steps towards a more data-driven company. And the bottom line challenges are really about the ability to create value from data for scaling the data usage and the adaptation of to new circumstances. Companies can really be at different stages with respect to these challenges. And just to illustrate, I make some examples and maybe you can relate to that. So maybe at the first stage, imagine you build a central data lake, you pump in all the data, but no one is really using that data. So you're not creating any value. In the second example, maybe you already demonstrated successfully some proof of concepts. You compiled long lists of many more data cases, but you kind of recognize that it's hard to implement all these. And so you are having troubles to scale the value creation. And lastly, maybe you already have a successful data platform with many cases being up and running. You have many users, but you see that over time, it's really hard to develop new things and operate the existing cases. So change is a big problem. And yeah, that's another challenge. So the root causes for this can be manifold. And just to name a few examples, could be that in these centralized architectures, you have specialized data teams which are a bit lacking the business know-how. You have unclear data ownership, or just the business in itself is so complex that you fail to kind of deal with these challenges. And so data mesh really attempts to solve these problems. When it comes to explaining what the data mesh is, I think the first key takeaway for the audience is that it's not just an architectural concept, but really like a new paradigm for scaling data management as a whole, with kind of a mind shift, also how to approach data governance and data culture. Data mesh has 4 core principles, and it's really important to know these. So the first one is domain ownership, and it shifts from centrally owned data to more decentrally owned data within business domains. So think of domains as different areas within your business which really take ownership instead of a central team. Second principle is data as a product. So having or owning data as an asset, it's already good because an asset is valuable to you. The mind shift is when you think about data as a product. So a product you want to share, and a product you have customers who want this product. So that's the mind shift. And if you incorporate this in your thinking, that's when you go towards the data mesh. Self-serve data platform, quite clear, I believe. It's instead of having a platform built for specialists, for data engineers or machine learning experts, you enable also generalists across the entire data journey on that platform. And lastly, federated computational governance. So instead of having a central group of data experts being responsible for governance topics, you have a federated team which sets global standards, but also that the execution in itself is kind of embedded in the platform and with a high automation. Just a few personal concluding remarks here. I think most undisputed of these principles is self-serve data platform. So everyone who I meet really thinks that's valuable. So there's broad acceptance that this you should aim for. Domain ownership, I think it's also a good concept, but it also is about allocating responsibilities. So you need to discuss this within your organization when you go into that direction. And I think data as a product and federated computation governance are the most innovative principles. But the good news is that you can really adopt these principles step by step, and also to a degree which is fitting your organization. So of course, the question for the audience is how do I start to build the data mesh? How do I start the journey? And if I have to pick just 3 success factors, I would pick the 3 following. So first of all, kind of to plan and structure your way forward, you can refer to the multi-plane data mesh reference architecture, which is made up of 3 layers. Bottom layer, kind of the infrastructure layer. So what services and tools do you want the platform users to provide so they can build data products faster, or also organize governance better. Then the middle layer, it's kind of the data layer, which is organized within the business domains. So here are really the the data engineers who use the services that you have on this data platform to build data products and deploy data products. And of course, here you have the data users, the analysts, the machine learning experts who consume the data. And on top, you have this governance layer, which is about finding data products, lineage, global standards, etc. Secondly, I think it's really important that you involve customers of your platform early on in your journey, because the chances are higher that you will kind of adopt more the domain thinking, because the customers typically come from business domains. So you have that discussion early on. And of course, maybe even more important is that you get feedback on your data products. And with that, you really create something which is valuable to the final customers. So that you should do early on in your journey. And lastly, of course, assess your starting point and then think about the incremental steps to develop further your platform. So what I see, there can be companies being at different stages. So maybe an initiative started very or more IT focused. So they are very advanced, maybe in the infrastructure layer with high automation. You have concepts like infrastructure as code. And then the next for you could be that you think about more the data products and how you can deliver valuable data products. Also, or you have more a mixed approach where you have both already some underlying infrastructure provided, and you have data products maybe starting within one business domain. And then you think, well, we really have a good concept here and you want to scale it to other domains. So then you need to think more about setting up the governance aspect more and more on maybe more automation, more scalability. So with that being said, I come to the last slide, and here I really want to give some concrete examples. So if you look at an integrated energy utility, you have certain business domains like energy generation, distribution, sales, and finance. I want to concentrate here on energy trading. And you have really that zoo of operational systems, so market data systems, energy trading and risk management systems, energy data management, assets optimization, or CRM systems. When we now look at the data products, datamesh has this concept of source-aligned, aggregated, and consumer-aligned products. And source-aligned is really about making the operational data more easily accessible to the users in a convenient way. Aggregated is typically also related to harmonizing data, maybe from different systems. And aggregated data, for example, could serve as a basis for self-serve business intelligence. Consumer aligned, it's really about new data products and creation of new data. So in my examples, I kind of structured them in clusters. So the first row is about position data, which is very important, of course, in energy trading. Second is about value, portfolio value, and P&L examples. And last row is about cash flow data. All these examples are super relevant right now in the energy trading business. So to finish this up, so what does these examples make data products? And I think you start making these data products when you think about, for example, the consumption actuals. When you start or think about the case when someone wants to do this forecast based on machine learning models. So you really need to share these actuals, maybe even with a different specialized data science team, which is not sitting within energy trading, for example. So you think about how can you share the data and also in which mode. So it's not sufficient to share with just one time series, but you need to really allow kind of batch mode for data science applications. So if you start thinking about these examples in these categories, then you start developing data products. And with that, I want to finish and hand over to Ricardo, who wants to talk about how HAKOM fits to the picture.
Thank you, Jonas. That was a great overview of the concepts. For my part, I would begin by taking a step back to look at how these evolving architectures fit within a theme that we have been covering here in our webinars for quite some time now. And those of you who have attended at least some of our previous webinars know that we often use the term data jungle to depict this unstructured architecture that emerges when you have numerous point-to-point connections that you have to put in place to fetch data from different systems which are located in different silos spread throughout an enterprise infrastructure. In the past, we have highlighted how a central middleware can help bring order to this chaos by providing harmonization based on a standard API. However, without additional clarification, this view may lead you to think that we're vouching for a centralized data lake, which in the context of what Jonas just described, is not exactly the scalable approach that we're aiming for. So this needs some rethinking. And we need to clarify how exactly this middleware axis in the middle of the diagram works. And with that in mind, we're going to change this picture just a little bit. So you could think of the data jungle as being several different puzzle pieces which don't always fit together in a nice way. Each domain, each business domain has their own source of data, their own choice of persistency, which can be databases of different types with very different schemas. And the applications each consume the data in a very different way. And bringing in the middleware layer reshapes your puzzle pieces into a more structured form. We still have the different data sources and applications, but now with several instances of your time series management component, which can actually be running in completely different domains. And here's the deal, since the time series management is actually decoupled from the persistency, you can serve the data from wherever it originates. This way you're really serving directly from the source of truth and avoiding costly ETL procedures, for instance. And with this, also getting around the issue of holding several instances of the same data in different systems, which brings all sorts of problems for versioning, for auditing, etc. So the picture that we're going to use going forward, once we take into account this distributed layout, is what you have in the slide. And I hope you will agree that this is more aligned with the concepts that we've covered here. But then the question we must pose is concretely, why should you opt for an off-the-shelf standard time series component when building or maybe renovating your data mesh architecture? And there's a few good reasons, I believe, which I would like to point out. The first is that the paramount concept in the data mesh architecture is serving the data distributedly, and this is happening right next to the sources. Now, if each source delivers data in a different format or through a different method or a different interface, you end up having to implement specific versions of all those transformations that should be generic. And this covers concepts which can be relatively simple, like converting between resolutions or units, but also more elaborate ones, such as aggregating according to different parameters, attributes, like Jonas mentioned in his second column. Also define a hierarchy for providing best values out of time series with different quality levels, or even more complex user-defined transformations. So the sky is the limit. And using a standard should be the basis to ensure there's interoperability between the different outputs of all the cells in your mesh for their applications. The second point is that almost by definition, each domain source will also have a different requirement for the persistency of the data. This can be due to having to deal with different volumes of data, different frequencies of updates, or requirements regarding transactional consistency, versioning, etc. So you will have maybe a traditional SQL database on some of the cells, a NoSQL storage on others, and maybe in some cases you're actually serving data from another third-party API, which completely abstracts the persistency. Now, the infrastructure to serve this data as a product to the outside world should accommodate all of them, because my application consuming the data in the end doesn't care about the choice of database in the background. I just want a particular data product for my use case. And this also goes the other way. The data product doesn't need to know anything about the application either. So you want a time series management layer that is polyglot with regards to the different persistency forms, while at the same time offering those standard features for data governance on top of the data storage layer, so that the applications consuming those products can rely on the same methods for accessing the data, to authenticate the users, etc. And finally, my third point is that the data mesh concept is very likely to be most meaningful in enterprises with very large volumes of highly heterogeneous data, so many different business domains. And if you're tuning in here today, chances are you're confronted with a big data use case in at least one of those domains. And very likely there are more than just a handful of domains that hold the data that could be of interest for those downstream processes or applications. So not only we have the need for standardized harmonization and support for different sources of data, which we covered in the first 2 points, but there will be a demand for resources to serve this huge volume of data, whether because the data sets themselves are very large or because there's a large number of users consuming it, so making up the volume from that side. And one way or another, that requires your technology stack to support growing with the storage and the compute requirements. So in other words, ideally you have the control to scale independently over both those 2 degrees. And I'll wrap up here saying that's precisely what Time Series Manager can do by virtue of the distributed architecture, which means you can add as little as 1 or as many as thousands of TSM containers at each cell, independently of each other, whether they are on-premise or in the cloud. And this way you can achieve that horizontal scalability on the compute dimension while using whichever database technology is required to address the scalability on the storage dimension on each of the domains. Now, if this all sounds interesting and you would like to explore how to bring this to your organization, we have a call to action.
The data mesh is the solution for the data-driven energy sector, and it can create a new path to a decentralized era. But before we start our Q&A, we want to make an offer. Let's discuss all aspects of scaling up your organization through the use of our time series technology by following the principles of data mesh. As every journey needs to be carefully planned, we have developed a model process to work out a clear proof of value. At the beginning, a team is selected. This team provides the right input about the relevant use case first. In a preliminary interview, the fine-tuning for the half-day workshop is done. The goal of the workshop is to describe the use case, agree on solution criteria, and finally, describe an implementation concept. We also provide implementation examples to take away based on relevant data and Power TSM, our cloud platform. The final follow-up is to decide how to proceed. Along with transparency regarding the solution, you will also have a clear plan for implementation, providing all costs and milestones for your specific use case. The whole process takes only 10 days in total, at a very reasonable price. Interested? Send a short message to tsmlab@hakom.at and we will send you a link to select an appointment. And now, let's start answering the questions. Back to you, Stefan.
I hope you will now call us for action. And now, thank you to both of you, Jonas and Ricardo. I've seen a lot of questions coming in now. Please go ahead. I will maybe start with one question to Jonas first. You mentioned 3 main success factors. What would you think is the most important one?
Yeah, probably I would pick the second one. So start early on with customers. So by that, even if you look at the other principles, you need to build something which really fits the needs of your customers, and that you should learn early on. So that I would definitely always do.
Okay, makes sense. Thank you. Another question came in: who owns the data product, and what if a data product needs data from different departments, planning, building, maintaining assets? Jonas, would you like again jump in according to experience?
Yeah, I can jump in. So I mentioned these 3 categories of source aligned, aggregated, and consumer aligned. So typically, I think rule of thumb is source aligned. The ownership stays with whoever the owner is of the operational data. So you could that could be kind of a business application owner, or maybe you also cluster along some topics. For example, price data, and these may come from different systems, but you have a data owner for price data. So in these examples, so source aligned, that stays as with the operational systems. Consumer aligned, I said that's a kind of a new product that's being built. So whoever builds that product should also own it. And aggregated, it's kind of in between. So it depends, I would say, how much you change from the source. If it's like simple modifications, I would tend to rather have it at the kind of at the source. If you do more complicated stuff, then it's more like a new product and would be having a new owner.
Thank you, Jonas. I've got one. It's a more longish one, but I think it aims out maybe to Ricardo. Now, there's also great scalability in centralized data management environments. Streaming ingestions also progressed a lot, real time, near real time. The only thing that's often unclear is the interaction between an application and centralized data. Yes. What do you think, Ricardo? How would we comment that?
There are different ways that an application can interact with the data, and say a request by a REST API is just one of them. You can also get bulk data directly in a CSV export, for instance. Ideally, your time series management or your middleware layer in between will have the capability to accommodate many different channels. For instance, TSM also support streaming through a Kafka connector. So if you have that type of volume of data, you can also tap into through the most appropriate channel. So it has one characteristic at the source, but maybe the way you're consuming it requires a different one. So ideally, you have the capability in the middleware to bulk those requests. If you have a data source that is providing data in a streaming fashion, but you need to consume it in bulks or the other way around. So ideally, you have this flexibility in your middleware to pick what is most appropriate for the application.
Thanks, Ricardo. Hope that wrapped it up. At Jonas, what did you learn the hard way in these implementation projects? What would you do different in new projects? So lessons learned, basically.
I already shared so many lessons learned. Yeah, as
maybe a bit about quick wins or
yeah, okay, quick wins, that's a good one. So I think you should really, like on your journey, you should really kind of carefully set intermediate steps so that you don't plan something which delivers only in 2 years' time, but maybe in like half a year time, quarter, half a year. I mean, like building big data platform would be a longer journey, but you should have these intermediate steps to provide some intermediate value, and also to engage your customers to demonstrate the value. And I think that's really important. So the worst that you can do is building something for many years, which in the end no one really needs.
Thanks, Jonas. I think again another one for you. Do we need a central governance to get an overall idea of the domains and data products in the whole organization and ask them to work together? Without central governance, how shall we catalog the data products and domains?
Yeah, so there are two questions. Really this one, so I maybe I can answer both. So yes, I think the idea of federated governance also has some centralization in it, in the sense that you set global standards. So I think if everybody, like each domain is doing what the domain wants, then you cannot scale. It's not interoperable, etc. So you need global standards. So that's very important. So there is something which is global central, but it's not coming from kind of outside the business or so. It's coming from the federated team. And yes, to me, like these data catalogs, they should be kind of a central point where any user could search for data products. And maybe also then the next question, if that's okay, Stefan, how to avoid data silos?
Yes, sure, go ahead.
I think that's a very good question, and that's why I wanted to answer this. I think you can approach it in two ways. So first of all, it's really like a cultural thing. So you should aim for, again, quick wins. So look for examples where you do something across domains and where you share data. But in the long run, you need to kind of lower the barriers to share. So that also has technical components, right?
Thanks. Well, I guess the sharing is a provision for the data mesh concept in any way. One to Ricardo, I guess. Does HAKOM TS, Time Series Management, have its own query language?
The TSM has its own API, so very extensive REST API with a number of methods for managing the data, for interacting with the data, and for getting hold of the data. It also offers a .NET or a Java API, and like I said, there's also other ways to connect to a time series repository with the HAKOM TSM on top. But in a sense, it's a standard API. It's not its own query language. So you're not introducing another new language into the applications that you would need to learn. It's all built on standards and supports, and it's extendable also by other protocols.
Okay, thank you, Ricardo. Then, according to time, I would say the last one in the official part of the Q&A. I'm a bit confused. Is data mesh mere an organizational or technical concept, or both? I kind of think I have to know the answer, but maybe Jonas, could you?
Yeah, to me,
your idea.
Yeah, I can take that question. For me, it's definitely both. So it has technical elements. For example, it lays out how you think about architecture in this multi-plane reference architecture, and this gives you also, like, you should think about how you could expose your data products via APIs. You should think about data catalogs, etc., etc. So that are all technical components. But the organizational part, it's really like this: how do you organize governance, federated teams, etc. So it's definitely both.
Okay, thank you, Jonas. As we are a bit over time already, I suggest that we now stop here with the official part of our webinar. But for those who have time, please stay, and we will continue answering some questions, because there are still some open questions. So please stay for another 10 minutes if you like. To all of you, thanks so much for joining again. I hope you liked our webinar, and you will stay tuned to us. Please also join the next time when it's time for time series next year. And so for those who do not stay, goodbye. Have a great winter time. And don't forget, life is a time series.